Now here we look at 2017, question 3, part B. All right, now this is a sort of a medium level question. Some easier bits, some harder bits. Looks horrific, and there is certainly a whole load of cosines and sines kind of coming out at us. Ultimately, the key to this question really is just a standard approach and knowing your trigonometry relationships. So let's have a little bit of a look at this kind of thing. So we have an inclined plane and particle shot upon it. And in this one, it's interestingly, we have theta as our angle for both of these, okay, which we don't often see. And again, we'll do a little sketch here of gravity, which is minus g because coming down that way. So we have theta in there, and there's our two little components. Okay, and that is minus g cos theta and minus g sine theta. All right, and of course, the eagle-eyed amongst you would realize I should have really done this as dotted lines are a different color, just to show that they are a different representation of the same thing, not all three happening together. Okay, and that was projected up with speed u, isn't it? Okay, we can ignore our line. The plane of projection is vertical and contains a line of graded slope, because that's just making sure that the whole thing makes sense mathematically. So show the range. Okay, so the range, okay, is distance in the I direction, okay, at t when distance in the j direction equals 0. So that's how we're going to, our little clue to figure out all of the range. The nice thing is here, we know what we're going for. Now, at a glance, having a look at this, there's something slightly weird here in the answer we're trying to get to. It's a cos 2 theta, okay? And we just need to keep that in mind that this needs to slot in there somewhere along the lines. Okay, so what have we got done? So let's figure out our range. So I'm going to use S is ut plus a half at squared. No harm to just pop that down there. This is how I'm doing this. So we look at the range in the j direction. Okay, so u in the j direction here. Now you can write these out if you need to, but at this stage you might be getting comfortable enough with them. That is going to be u sine theta, all right, by t, plus a half. And acceleration in the j direction is going to be minus g cos theta, and by t squared. And that is, of course, equal to 0. So the nice thing of that is you can see that we're going to get one of these each side. So let's just do a little bit of housekeeping and tidy this guy up here. 0 equals u sine theta t minus g cos theta all over 2 t squared. Okay, bringing this guy across. So we end up with g cos theta t squared all over 2, just going across this side, equals u sine theta over 1, just out of habit there. So what we'll notice is, of course, one of the options is going to be t equals 0, and that's fine because that's at the very start, t equals 0. So we can ignore that t, we're not interested in that, we're interested in t at the end. So we'll just divide across, and t is, well, the 2 goes up there, 2u sine theta all over g cos theta. Okay, so that is our time when it lands. Now that we have that, of course, we need to go off and figure out what is the SI, the range. That's all right. So I'll start this one up here, get a nice fresh start to the whole thing. So SI, and again, we're just going to use ut plus half at squared. It works really well for these ones. Okay, so this one is going to be u cos theta. Is it u? All right. Now I'm just going to write this out for the moment so we can kind of see where it's going, and then we'll sub in the t. And that is a half. And acceleration here in this direction is minus g sine theta t squared. Okay, this one is going to get a bit messy. I'm going to warn you now. So there's no harm, just make sure we lay things out nice and clear. Okay, so the next step here is to sub in t. Sub in t. And so I'll just actually call this the range, so we know exactly what we're talking about. U cos theta by this guy here, 2u sine theta all over g cos theta. Okay, oh, it's going to get better. minus g sine theta all over 2 by this guy. Du sine theta all over g cos theta. Fun times. Okay, just make sure we're on the right track. Now we can do a small little bit of housekeeping here. Let's see, we can knock out that guy and that guy, the two g's there. We can knock out the 2's. And we can knock out the cos thetas. All right, let's do some housekeeping and then we're going to aim for a common denominator. So I have 2u squared sine theta all over g. Okay, minus. Now remember that guy, this is where we need to be very, very careful here. That was, of course, t squared. So I cannot knock this out. I'm going to leave that there, I'm going to leave that there. That's an easy way to have a little slip on things. And of course, we'll leave that there. So we'll just ignore, we'll basically say don't cancel. Because you want a squared before you start cancelling. It's an easy way to kind of make a little bit of a screw up. Okay, so let me just figure out what we had here. We had g sine theta all over 2. And now we're going to square this guy, 4u squared sine squared theta all over g squared cos squared theta. Okay, now it is worth taking a little moment. This is the kind of common place you tend to make a slip and go wrong, and you can kind of see where things come out. Okay, I have a g on the bottom, I have g squares and so on. So we can do a little bit of cancelling here. Okay, now it's safe to go. The g squared and the g can go. Okay, the 2 and that goes back to 2. All right. Oh, this is nice. I have u squares. I have a few things in common here. So let's see. We have 2u squared sine theta all over g minus 2u squared sine cubed theta. Fantastic. Okay. All over g cos theta squared. And then we just write the square in there. Now I'm just going to make sure, because that is a slightly messy one, make sure we got all our bits and pieces into it. Okay, so we did. Now, next step here is I need a common denominator. Now let's check and see in our question, and we are of course looking for this guy here. That's the denominator from the question. Okay, so that's good. So I'm going to convert this one to that, and off we go. Okay. So we just multiply by cos squared theta, u squared sine theta cos squared theta. Okay. Minus, this is just the same, 2u squared sine cubed theta all over g cos squared theta. So we're getting there. Now at this point, I'm going to have a little bit of a look. We're getting close. What do they want us in the question here? I had my sine theta, so this whole section, if it's right, it's just as cos squared. And actually, we can pull this section out of it. Okay, so we're going to take this little piece here, okay, and we'll take it out. Okay. Outside the brackets really is what I mean with this. Let's see what we've got left then. All right, and that's going to be 2u squared sine theta by cos squared theta minus sine squared theta all over g cos squared theta. Now, there's two ways you can go with this one. First of all, you can have a little look and you realize the only difference you have here is that that is cos 2 theta in the actual, in the question we need to get to. You could also look at this and realize, I think I spot a little bit of a trigonometry relationship. And if you go to page 14, you will realize, of course, that this is your double angle formula. So this bit here, put that in the little box. And that, of course, equals cos 2 theta. All right, you don't need to memorize these, but you do need to know they exist. And when you get to that little stage, check your trig relationships, all sorted, and we end up with the range, of course. Bring this down here. 2u squared sine theta cos 2 theta all over. Okay, and we'll just check that is actually what we're looking at in our question. Yes, indeed, just added order. G cos squared theta. There we have it. And just a little bit of a QED, quadrat demonstrandum. There you go, I showed you. Okay, so part 1 sorted out. Now, what about part 2? If the particle strikes inclined plane at right angles, then the range is this. Well, if it lands here, okay, and that's the plane, at a right angle, well, what do we know? Well, this is our J direction or I direction. Okay, so what we know is we know that the velocity I direction equals 0 at landing time. Alright, well, let's see what we can do with that. Now, there's a few ways, there are at least certainly 2 clear ways you can kind of go at this one. Okay, first of all, what's the velocity in the I direction? Velocity in the I direction, okay, I'm going to use v equals u plus at. It's kind of the handiest little one to do. Velocity in the I direction is, well, u is u cos theta in the I direction, and it's going to be slowing down. If we go back to our little drawing here, minus g sine theta, that's what's slowing down. So 2 ways you can go at this one. You can either say that this equals 0, and you'll find this here, or you can use t from before. Okay, so there's not really much to it. I'm going to use t from before. Okay. It really isn't, whatever your preference is. I think the marking scheme sets this to 0. Anyway, so let's stick this in. So we know that that is u cos theta minus g sine theta, and my t from before is just, if we go back here, it's that t, because we know that's when it lands. I'll put it up here so I can see it. 2u sine theta over g cos theta. Okay, so a little bit of cancelling and tidying. Now, this is kind of a nice one actually to bring it out. What do we have here? We can cancel out our g's, and that's good. We want to get rid of the g. Okay, we're now just down to the u's. So what we have is 0 equals u cos theta minus 2u sine squared theta, okay, all over cos theta. Let's start tidying this all up here a little bit. Am I missing a u somewhere along the way? No, I have my u's. Okay, so what have we got? Put this over this side, sign up with u cos theta. I'm going to do it in 2 lines, but I would bring that up and squared, equals 2u sine squared theta over cos theta. All right, now I'll cancel my u's. I did want to get rid of them. Looking good. Bring that across. Cos squared theta equals 2 sine squared theta. Okay, so I've got a problem here. I've got to express in sines and cosines. So what I want to do is think about tan. All right, if I can get this an expression of tan equals a half or whatever it is, then I'm sorted. Of course, I can do that. Okay, so tan is, what we're going to get is we get sine squared over cos squared. So sine squared theta all over cos squared theta equals, and those 2 goes on the other side, equals 1 over 2. And that, of course, equals tan squared theta. Equals 1 over 2, which means tan theta equals 1 over root 2. All right, now I have tan theta. What's 1 over root 2? Now, this is where you need to stop and think. Okay? Stop. Don't solve. All right, don't solve for theta. You're only making your life hard. Okay, what are we going to do instead? We're going to figure out that I'm going to draw a little triangle. So let's go off and draw it, do it on this side here. If tan theta is a half, there we go. There's theta. Opposite over adjacent, 1 root 2. Okay, and this is square root of 1 squared plus 2 squared, or it was root 2 squared. So it's the square root of 2 plus 1, and that is the square root of 3. So therefore, sine theta is 1 over root 3. Cos theta is root 2 over root 3. Now, where are we going next? So let's say we need to show that the range is going to be equal to something. Now, what we're going to have a look at is we bring back our range formula. We do have a slight problem here, is that we got this 2 theta. So the solution is simply just go back a step and we'll use this guy instead. Okay, it's a little bit uglier, but I have all these bits, so it'll come out together. So what we'll do is we'll just figure out sine squared theta. I want to write these out. 1 over 3 cos squared theta is 2 over 3, just so we know for sure. So the range, okay, and I'm going to be taking this guy here, all right, 2 u squared sine theta, 1 over root 3, by cos squared theta, 2 over 3, minus sine squared theta, minus 1 over 3. It's actually not so bad when you're going to crank it out, all over g cos squared theta. So g by 2 over 3. Now, a bit of housekeeping. I'm going to just go across a small because I am getting tight in the page here. And that is, what have we got? We'll sort this guy out first. So that's 2 u squared. Okay. By 1 over root 3 by 1 over 3. All over 2g over 3. So let's multiply everything below by 3. We'll get rid of that. And then it's going to be equal to 2u squared over root 3 all over, so I'm kind of getting rid of that guy there, all over 2g. And that is going to be equal to, well, now I can get rid of the 2's. What have I got? U squared over root 3 all over g. And if you get confused on how to kind of write these ones out, you can see where we're kind of going with the answer in this one, but it's going to be, you can break it up this way, u squared over root 3 multiply by 1 over g. And that, of course, equals u squared over g root 3. And there we have it. All right. Sometimes breaking this out like this, you know, it can make dealing with these messy fractions a whole lot easier.